Okay, we're talking about partial fraction decomposition, and you might have seen my previous video about distinct linear factors. So now we're going to talk about the case of repeated linear factors, which is quite interesting as well. So what we're going to do is we're going to take a look at this and say, okay, well, there's a denominator, really the same denominator, x minus 6 quantity squared. So what if we wrote it out like this? Well, x minus 6 and x minus 6. Well, there's a problem with this because the denominator here is x minus 6 squared. Now, you have to consider when you're adding fractions, if the denominator is the same, which we always want, it makes life so much easier when that happens. But if the denominator is the same, then we just add the numerators, right? But in this case, it doesn't work out like that. Okay, it doesn't work out like that. So what we're going to do is we're going to write this second denominator as x minus 6 quantity squared. Okay, and in the top, we're going to put a and b. Now here's the trick to figuring out about a and b. And we're going to get into another video where we talk about linear and quadratic factors, but your a and your b will always be 1 degree less than whatever is in the denominator. Okay, so this was x minus 6, so the a has to be a. Okay, the number on top is just a. If it was something like x squared minus 6, then this would not be a, it would be ax. Okay, and then you'd have to add in actually another component, let's say c. But that's a story for another time, and we're going to stick with what we've got. But there's going to be another video, the third case rather, where you're going to figure that one out. So we'll save that for later. All right, but let's take a look at this one. So what we're going to do, same thing that we've been doing, which is clearing the numerator and, well, really clearing the denominators by multiplying everything by whatever the common denominator might be. So something looks like that, and this ends up crossing out. We end up with 3x minus 22 equals, and we're going to be left with over here x minus 6 squared over x minus 6, a times x minus 6 plus just a single b, because what ends up happening here is this crosses out, and over here only one crosses out, so you're left with just crossing out the 2, and a gets multiplied by x minus 6. So it looks something like that. All right, now we go back, discussing wise choices for x. What can we pick for x that might help solve for either a or b? Well, if we plug in the fact that x minus 6 equals 0, x equals 6, so if we plug in x equals 6, that will actually help me solve for b. So let's do it. 3 times 6 minus 22 equals a times 6 minus 6 plus b. So 6 minus 6 is 0 times a, that's 0. And the a component is gone. So then we have 18 minus 22 equals b. And then negative 4 equals b. So b equal, just read it backwards, b equals negative 4. Okay, so we've found our b value. Now we're going to go and solve for a. The trouble is we don't have anything with b that we can necessarily cancel to solve, so we can use the fact that b is negative 4, right? We already know that part. Okay, we know that fact. So now we ran out of wise choices, so let's pick good choices for x. Something that'll help make our life really easy. Good choices for x are simple values like 0, like 1. If you can get away with plugging in 0, plug in 0. All right? If you can't plug in 0 for whatever reason, another good choice is 1. but let's go with 0 because I think it's just going to be so much nicer if we just keep it simple. So again, we ran out of wise choices. Wise, when I say wise choices, it's because it's something that will help clear one of the A's or B's. So we go with x equal 0, and we're going to end up with 3 times 0 minus 22 equals A times 0 minus 6 plus, and in this case, negative 4, since we found out from the previous step that B was negative 4. The 3 times 0 cancels. We're left with negative 22 equals, and we're going to have negative 6A, because 0 minus 6 is negative 6, minus 4. So now we have a very elementary equation that we solve. We add 4 to both sides. We get negative 18 equal negative 6A. And if you know some very simple arithmetic, you should know already what this answer is. The fact that A equals 3. So A equals 3, B equals negative 4. Let's go back. We're looking way back over here at this decomposition. Okay. We're going to look at that, and then we're going to write out our partial fractions. And I suppose I can write them right in here for you. I think this will be a good spot. Box it in maybe right here. All right, I'll pick a different color if it helps. So A was 3 over x minus 6, and B was negative 4 over x minus 6 quantity squared. So this is how you would approach a partial fraction decomposition when you have the case of repeated linear factors. So if this video was helpful, if you liked the video, be sure to like the video and subscribe to my channel. Good luck with